Video, I want to talk about how to solve a system of equations graphically. So basically we talked about in the last video that the solution to a system of equations is the place where those two linear equations cross or where they meet. So in order to solve it graphically, we just graph them very carefully and then we figure out where they meet, and that's the solution. So let's look at this first one. Y plus 6 equals x and y equals negative x plus 4. Okay, so first I want to put this into y equals mx plus b format, so I'm going to subtract 6 from both sides. So y equals x minus 6. Okay, so y equals x minus 6 is an equation that, that goes through negative 6. So 1, 2, 3, 4, 5, 6. So the y-intercept is negative 6, and then it goes up 1 over 1, up 1 over 1. Okay, so that's this line right here. So this is y equals x minus 6. And now we want to graph y equals negative x plus 4. So here, let's go this way now. So now we have y equals negative x plus 4. So it's going to go through, the y-intercept is going to be 4, but it's going to go down 1 over 1. So this is what this line is going to look like. And I'm just using the fact that my ruler tool tells me that the angle, so I know that a y equals x line has a 45-degree angle. So I'm using that to graph it easily, but you can use the slope, up 1 over 1, up 1 over 1, and so on. So in this case, we have our point where they meet, which is right here, which looks like 5 comma negative 1. So the point where they meet is 5 comma negative 1, and that is the solution to this system of equations. Okay, so let's try another one. Let's try this one. So the first thing is going to be to get it into y equals mx plus b form, so I need to work on this one and divide everything by 2. So we have y equals negative 1/2 x minus 3 over 2. Okay, so let's graph this pink one. So we're going to start with the y-intercept. It's going to be 2, and then we're going to go down 1 and over 2, and so on, down 1 and over 2. So I'll use my ruler again. Okay, so this line is going to look like this, and this is y equals negative 1/2 x plus 2. Okay, so now we have y equals negative 1/2 x minus 3/2. So minus 3/2 is like right here, and then we go down 1 and over 2. So that's going to be like right there, and then down 1 and over 2. It's going to be right there. So when we graph it, it is going to look like this. All right, so where do these lines intersect? This is y equals negative 1/2 x minus 3/2. So you may have noticed that they don't intersect, and that's because they're parallel lines. So whenever we have parallel lines, these have no solution. There's no place where they both intersect. There's no point that satisfies both of these equations. So there's no solution. And this system of equations is called inconsistent. Basically, that just means it can't have a solution. It's inconsistent. There's no way to make this work. Okay. So that's that kind, and that's a possibility when you're solving systems of equations. It's possible that they'll be parallel and therefore that there will be no solution. Okay, let's look at this last possibility. So we have y equals 2/3 x plus 1. So 1 is our y-intercept, and then we go up 2 over 3. And let's put our line right here. Okay, so it's right about there. And then if we look at this line, we need to solve for y first, so let's divide everything by 3. So we get y equals 2/3 x plus 1. Okay, so that's 1. And then we go up 2 over 3. Okay, so the points are exactly the same, right? Which means it's exactly the same line. And so these lines are right on top of each other. They're actually the same thing. And that means that any point on these lines is a potential solution to this system of equations. So it has infinitely many solutions, right? Any point you pick on that line, going on forever in both directions, is a possible solution to the system of equations. So we call this infinitely many solutions. Okay, please do not call it all solutions, because you'll notice that there's a whole world out here, like all the points over here going on in forever in these directions, and all the points over here going on forever in these directions. These are not solutions, right? None of those are solutions. So it's not all solutions, but there are infinitely many solutions on this line. Every single point on that line, decimal, fraction, whatever, every single point on this line is a solution to the system of equations, and there's infinitely many of them, but not all solutions, just infinitely many. All the points on this line are possible solutions. Everything else is not, but we can call that infinitely many solutions if the two lines are actually the same. So when you're solving systems of equations, there's 3 possibilities. One possibility is that they'll intersect in a single point. Another possibility is that there'll be parallel lines and there will be no solution. And the third possibility is that they'll be exactly the same line and there will be infinitely many solutions. And that is how you solve a system of equations graphically.